Hello everyone. Today we're going to cover data handling with Pandas. So here are some essential Python libraries. So what we mean by library is a collection of functions and methods that allow you to perform lots of actions without writing any code. Uh, the libraries usually contain built-in modules providing different functionalities which you can use directly. And you can see there's a NumPy, Pandas, Matplotlib, Jupyter, SciPy, scikit-learn, and StatsModel. So when you are computing, uh, here are out of those libraries that we looked at, here are computing libraries in Python. So, uh, and these three are major libraries for data analysis in Python. So first one would be Pandas, and Pandas offers data structure and tools for effective data manipulation and analysis. The library provides facts access to structured data. So the primary instrument of Pandas is the two-dimensional table consisting of column and row labels, and they are called a data frame. And this data frame is designed to provide easy indexing functionality. The second one that you will probably deal with is NumPy. So NumPy is very similar to Pandas. Uh, the difference is that NumPy library uses arrays for its inputs and outputs, and it can be extended to objects for matrices, and with minor coding changes, developers can perform a fast array processing. And the third one is SciPy. So SciPy uh, includes functions for some advanced math problems as well as a little bit of visualization. So, for example, if you're interested in solving differential equations, if you're interested in doing like optimization, you would look into methods and functions in SciPy. Pandas, since its emergence in 2010, it has helped enable Python to be a powerful and productive data analysis environment. So the primary objects in Pandas that will be used in this course are like the data frame, which is a tabular column-oriented data structure with both row and column labels. And you will occasionally use the series, which is a one-dimensional labeled array object. So what Panda does is Pandas blends the high performance array computing ideas of NumPy, but also has the flexibility in terms of data manipulation capabilities of spreadsheets and relational databases such as uh, SQL. So Pandas provides uh, indexing functionality to make it easy to not only reshape, but also like slice and dice and perform aggregations. And you can easily select subsets of data. And since data manipulation, preparation, and cleaning, uh, though all those three are such an important skill in data analysis, Pandas is one of the primary focuses among Python libraries. So NumPy, we when we look at NumPy, you can see that NumPy provides like the data structures, algorithms, and library glue needed for most scientific applications involving numerical data in Python. So beyond the fast array processing capabilities that NumPy adds to Python, one of its primary uses in data analysis is as a container for data to be passed between algorithms and libraries. So for numerical data, NumPy arrays are more efficient for storing and manipulating data than the other built-in Python data structures. So we're gonna talk about SciPy. So SciPy is basically a collection of packages addressing a number of different standard problem domains in scientific computing. So you would use like SciPy stats to maybe find out like the continuous uh, find out and use continuous and discrete probability distribution, various statistical tests, more descriptive statistic tests. So with NumPy and SciPy, you can form a reasonably complete and mature computational foundation for uh, any traditional scientific computing applications. So uh, visualization libraries. So using data visualization methods is the best way to communicate with others, showing them meaningful results of analysis. And these libraries usually enable you to create graphs, charts, and maps. And the matplotlib package is the most well-known library for data visualization. It's great for making graphs and plots, and these graphs are also highly customizable, and uh, it's designed for creating plots suitable for publications a lot of times. And while there are other visualization libraries available to Python programmers, I would say Matplotlib is the most widely used and has generally good integration with the rest of the ecosystem. So if you're using Python and Jupyter Notebook exclusively, I think it's one of the safe choices as a default visualization tool. Another high-level visualization library in Python is Seaborn. Seaborn is based on Matplotlib. So what Seaborn did was they made it convenient to generate various plots such as heat maps, time series, violin plots, and so on. Let's look at algorithmic libraries. So we have scikit-learn and stats model. So with machine learning algorithms, we are able to develop a model using our data set and obtain predictions. So the algorithmic libraries tackles the machine learning tasks from basic to complex. And there are two major um, ones, scikit-learn stats model, and scikit-learn library contains tools for statistical modeling. And when we talk about statistical modeling, this would include regression, classification, clustering, and so on. So this library is built on NumPy, SciPy, and Matplotlib that we talked about. And stats models is also a Python library that allows users to explore data, uh, estimate statistical models, and perform statistical tests. So scikit-learn it has become really popular general purpose machine learning toolkit for Python programmers. In just 7 years, 7 to 8 years, the library has had over 1,500 contributors from around the world. So the scikit-learn includes submodules for such models as uh, classification, regression, clustering, dimensionality reduction, model selection, pre-processing. For classification, uh, there are like SVM, which is the four vector machine, nearest neighbors, random forest, logistic regression, etc. For regression, they have like lasso, ridge regression. For clustering, they have k-means, spectral clustering, and for dimensionality reduction, there's feature selection, matrix factorization. For model selection, there's grid search, cross-validation metrics, and for preprocessing, there's feature extraction, normalization. So stats models is a Python module that focuses on statistical inference and provides uncertainty estimates and p-values for parameters. So what's the difference between scikit-learn? So compared to scikit-learn, I'll say stats model is for more classical statistics, econometrics. Scikit-learn is more prediction focused. Jupyter, you might have already interacted with Jupyter Notebook, already have it on your computer. It's a system that allows you to create contents in Markdown and HTML. The most powerful thing about Jupyter Notebook is that it creates a document with code and text together. So importing data, in order to read any data using Python's Pandas package, there are two important factors to consider: format and file path. So format is the way data is encoded. We can usually tell different encoding schemes by looking at the ending of the file name. So some common encodings are CSV, JSON, XLSX, HDF, and so forth. And the path tells us where the data is stored. Usually, it is stored either on the computer we're using or online on the internet. So if you're interested in importing a CSV into Python, you would want to first import pandas as PD and have a define a variable with a file path, and you want to use read CSV method, which can read in files with column separated commas into a pandas data frame. So uh, one thing you want to keep in mind is that read CSV as a default makes an assumption that the data contains a header. You can pass more configurations in read CSV to make changes. So if you want to import a CSV into your Jupyter Notebook Python without a header, uh, you can specify read CSV to not assign headers by setting header to none. Creating data. So there are two core objects in Pandas, the data frame and the series. So data frame is basically a table. It contains an array of individual entries, each of which has a certain value, and each entry corresponds to a row and a column. So if you look at the example, if you look at the left, you can create uh, your own data frame by saying, by pro, by calling data frame method and uh, providing what the values are. Uh, I Here are two examples. So data frame entries, as you can see on the example, right, it's not limited to integers. So creating data, you can, we are using the PD data frame constructor to generate these data frame objects, and the syntax for declaring a new one is like a dictionary whose keys are the column names. So if you look at the second example, uh, you see Bob and Sue, and whose values are a list of entries. So this is like a standard way of constructing a new data frame. And this is like the ones that you're most likely to encounter. So after reading the data set, it is a usually good idea to look at the data frame to get a better intuition and to ensure that everything occurred the way you expected. Since printing the entire data set may take up too much time and resources, to save time, so we can just use methods such as data frame head to show the first n rows of the data frame. Similarly, you can use data frame tail to show the bottom n rows of data frame. And if you're interested in how large the data frame is, you can call data frame shape. So here are some uh, ways to export to different formats in Python. So if the data format that you're interested in is CSV, in order to read, you will need to call read CSV. If you want to save, you want to uh, look at the data frame that is already stored and call to CSV. Similarly, for JSON, Excel, SQL, you can do the same. So indexing, it's one of those first things you will need to learn in working with data in Python is how to go about selecting the data points relevant to you quickly and effectively. So it means if you have a Python dictionary, you can access its values using the indexing operator, and we can do the same with columns in a data frame. So indexing in Pandas, Pandas has its own accessor operators. One's loc and another is iloc. So if we talk more about index-based selection, uh, so this is one of the two paradigms. You're selecting data based on its numerical position of the data. For this case, you want to use iloc to And if you're interested in label-based selection, uh, you are you want to refer to the data's index value, not its position. So another thing that is used a lot is summary functions. So uh, the data may not always come out of memory in the format we want it right out of the bat. So sometimes we want to do more work ourselves to reformat for the task at hand. So uh, this summary functions helps you to restructure data in some useful way. So that this describe method, when you call that, it generates a high-level summary of the attributes of the given column. So if you want to get some particular simple summary statistics about a column in a data frame or a series, uh, you want to uh, look at there there are helpful functions, and one of them, uh, as you shown in here, is a mean function. So you can call a mean method. If you want to see a list of unique values, you can use the unique function. So here, if you have reviews and taster name, and if you do unique, it will only return the unique value. So if you are more familiar with SQL, this is equivalent to um, select distinct. To see a list of unique values and how often they occur in the data set, you can use the values counts functions. And I want to talk about map. So map, a map is a term. It's borrowed from mathematics. And this is a term for a function that takes one set of values and maps them to another set of values. So in data science, we often have a need for creating new representations from existing data, or for transforming data from the format it is in now to the format that we want it to be in later. Maps are what handle this, what makes making them extremely important for getting your work done. So uh, the function that you pass to map will expect a single value from the series, for example, and return the return a transform version of that value map. So if you take a look at this example, this function remean points, it looks at row points equal row points minus review points mean and returns row, and you would apply remean points and axis column. So you do this if you want to transform the whole data frame by calling a custom method on each row. Now, grouping and sorting. So group by, what it does is it creates a group of reviews which allotted the same point values to the given. Um, so for each of these groups. So you would kind of grab uh, points column and counts how many times it appears. So value counts is uh, what just like a shortcut to this group by operation. Another grouping and sorting method worth mentioning is aggregation, which lets you run a multiple functions on your data frame simultaneously. So if you look at this reviews group by country, you can, for price, you can do you can get the length, min, and max. You can calculate them simultaneously and it will return the result of length, min, max for all countries. So data types. So the data type for a column in a data frame or series is known as D type. So you're using the D type property to grab the type of a specific column. So to look at this example, you can, given you have wine data, you can get the D type of the price column in the data frame. So data types tell us something about how Pandas is storing the data internally. If you find float 64, it means that it's using 64-bit floating point in number. If you see there's an int 64, it means there's a uh, integer instead, but the integer is a 64-bit. So in computer memory, they both take up 64-bit. One interesting thing to keep in mind is that columns consisting entirely of strings do not get their own type. They instead are given the object type. As you can see, country, description, variety, winery, they all get the type object. So when you work with pandas, you would often have a need to convert a column of one type into another. When that need arises, you want to use this method called sType. So if you look at this example, this allows us to convert points into float 64. When you deal with data, specifically data that is coming from user, uh, you will often see a lot of missing values. And pandas provide some methods specific to missing data. So when you're given value NaN, which is a short for not a number, you can use PD that is null method to select the null entries. And whenever you select missing values, replacing those missing values is a common operation. What Pandas provides a handy method for this problem, which is called fill NA. And this fill NA method provides a few different strategies for mitigating such data. To give you an example, we can simply replace each NaN, not a number, with an unknown. Here's renaming. So sometimes the data you have might have column names, index names, or other naming conventions that we're not satisfied with. So when you run into that case, you want to use pandas functions to change the names of the entries that you want to change to something better. So the first method that we want to introduce is a rename. It lets you change index names and or column names. So for example, if you want to change points column in a data set to score, you need to uh, call rename and then provide uh, columns and set points to score. Another thing, this rename method lets you rename index or column by specifying a index or column keyword operate parameter. So here you can see when we rename, we provide 0 and 1, and we can by providing 0 as first entry, the first row has an uh, name first entry, and the second row has name called second entry. You oftentimes need to combine, and the simplest combining method is concat. It's short for concatenate. So given a list of elements, this function will kind of smoosh all those elements together along an specific axis. And this is useful when you have data in different data frame or series objects, but having the same fields. Lastly, in combining, so you would often need to use join. What join does is join lets you combine different data frame objects which have an index in common. So if you look at left, which is a Canadian YouTube, and right, which is British YouTube, and if you want to join, you need to specify uh, the L suffix and R suffix. That's it for introduction to pandas.